Hi guys, this is Mrs. Gastler, and in this video we're going to talk about position, distance, and change in position. We have some notes pages for this, so if you'll find those. Let's see, this year they're on pages 14 to something else. If it's a different year, I don't know, you'll have to find them. Okay, what is position, distance, and change in position? This is what it looks like. Alright, so position, you might already know this, tells you where you are, okay? And it's always measured relative to something else. And in physics class, when we talk about the position, we use the letter X. So that tells you your position, okay? So if we take a look, we've got a picture here and some things that we're going to find the position of. So we've got a sink and a camera and a plant, and we've got a number line. And our number line has a unit on it because that tells us what unit we're measuring in. So when we find the position of the sink, it's over here. I could write X with a little s for the sink, you know, like we were labeling other things with a subscript to tell us what they are. And then I would write that it is at 0 meters. I've got to include the unit, and it's an M for meters. Okay. The position of the camera is right there in the middle. Okay, so X for the camera. I'm just going to write a C for camera. It's at the 5, so I'm going to put 5 and also the meters. Okay. And the plant is way over here. Hopefully you can tell that the position of the plant is 12 meters. So when I find the position, I'm literally just looking where it is and telling where it is on the number line. Now here it says to place a pumpkin at the 8-meter mark. Okay. Got to be honest, I can't draw very well, but I can place a pumpkin at the 8-meter mark. So we'll make a, let's see. Does that look like a pumpkin? Hopefully that looks like a pumpkin. And notice how I put it at the 8. Just like these other guys were at those numbers, this one's at the 8. Okay? So that is position. That's probably the easiest part of this. Next we're going to talk about change in position, and this one might be a little bit trickier to understand, and also not. Okay? When we say change in position, what we're talking about is how far an object, whatever we're talking, is from where it started, okay? From where it started. So when we move something from one place to another, it has changed its position. Change in position would tell us how far it is from where it started. Now the symbol that we use for it looks like this. It's a triangle and X, okay? With a different marker here. The triangle literally means change in. I think sometimes you use that in math class. If you haven't yet, you might someday, okay? And when we're trying to find the change in position, we're going to take the final position and subtract from it the initial position. And the reason we do that that way, especially on a number line, is that if something goes in that direction, we're kind of subtracting from the number. So if we start at the 8 and we go this way, we're going to be subtracting, so our change in position would end up being negative. So it's important that the final always comes first and you subtract the initial. Okay. So for our example, we've got something here. It says the camera is going to move from the 5-foot mark to the 8-foot mark. Okay, so here's the 5-foot mark and here's the 8-foot mark. Okay, so this is my initial position and this is my final position. So when I find the change in position, final minus initial, I am going to take the final, which is 8, and this time it's feet. 8 feet minus 5 feet. When I plug that into my calculator or do the math in my head, 8 minus 5 is 3, so this is 3 feet. Okay. Unit check. We also have to make sure our units match. If our units don't match, we're going to have to change one of them so that they are the same. So that doesn't happen very often in this class, but if you had centimeters and meters or feet and yards, you would have to do some conversions there. The change in position, another word in physics class that we use is called displacement. That's the fancy way to say change in position. Okay. And here's another example. This one's going to be a little different. In the picture below, the camera is initially at the 6-foot mark. That's our initial position. And it moves so that it is 2 feet from the sink. That is our final position. How much did its position, whoops, I put a T for feet. How much did its position change? Okay, so this time, same equation. xf minus xi. This time my final position is 2, and I'm subtracting 6. Oops, I forgot the feet. What happens when you get 2 minus 6? When your first number, when you're subtracting, is bigger, you're going to end up with a negative answer. I'm sorry, when your first number is smaller, you're going to end up with a negative answer. So we're going to get negative 4 feet. And remember that negative just means we went this way on the number line. Okay. And so that's what we're going to write here. So a positive x indicates that the object is moving in the positive direction. And a negative change in position would indicate that it's moving in the negative direction. So all that negative is doing, it's telling you which way the object is going. Okay. So that's change of position. So up next we have distance. Okay. Distance is definitely related, but it's a little bit different. So when we talk about distance, we're talking about the length of a path that has been traveled. Okay, so the distance is a little bit different. I like to draw this picture where I have a starting point and an ending point, and maybe I follow this path to get there, or maybe I follow this path to get there. Okay, one of those is definitely longer, right? The distance is the length that I follow. Now there's a straight line distance right here that we could talk about, but if I have to follow this path, the distance is going to be different. Distance is used a lot when you're driving, because you can't drive through houses and fields and on things that aren't roads. So the distance that you travel to get to a location may not be the same as the distance in a straight line from one place to another. You may also go a different direction to get there and travel a less distance or more distance. We use the letter D for distance, and if you're trying to find the distance, you might have to add up little pieces of distances. Depending on what you have to look at, you could add up all the pieces and you would end up there. We don't use any negatives, okay? Distance doesn't care what direction you're going, it's just the length of the path. Okay, we could turn the path this way and it would still be the same answer, even though maybe it would look a little bit different on the thing. So there is a chance that distance and displacement could be the same, and the only time that is going to happen is if the path is a straight line. Anytime you don't go in a straight line, your distance and your displacement won't be the same. Okay. So if we go from A to B in a straight line, then it'll work. All right. So now we're gonna do a little bit of practicing. Okay. So we have a bug. It travels from the camera, so it's going to start here. We'll call that XI. It's going to go to the plant. I'm going to kind of trace its path here. So that's there. Oh, I'm sorry. It goes to the sink. Let's pretend that's not there. We'll just draw a fat line. It goes to the sink, and then it goes to the plant. There we go. Okay, so here's our XF. Goes to the sink and then to the plant. There we go. Okay, so we want to find the distance traveled. So what we're looking for is the length of this line. Hopefully you can see that I can measure it in 2 pieces. So I'm going to write that I'm going to measure it in 2 pieces. Okay. In the first piece, I'm going from the 8 to the 0. Okay, again, I know it's going in the negative direction, but I'm not going to include the negative. So this is 8 feet. There we go. 8 feet. And then I'm going from the sink to the plant, and that is from 0 to 12. So that's 12 feet. When I add those together, 8 and 12 make 20 feet. So that's how far my plant traveled. Okay. That's the length of the path. Now for the change in position, we're really only looking at where it started and where it finished. So it's that final position minus that initial position. So my final position is 12 feet, and my initial position is 8 feet. Okay? So when I go 12 minus 8, I get 4 feet. So this is how far it went, and this is how far it is from where it started. Okay? So that's the difference between distance and displacement. It's a fun thing to calculate. Okay? All right, last page. One more example, and then we'll do a little bit of summing up, and then we're done. and you can go and work on the next thing, okay? All right, so we've got, apparently you live in Paris. That's really lucky of you. I think it might be expensive. You better watch out. Don't spend all your money in one place, okay? It says the airport is over here. It says 20 kilometers to the west of the tower, but that definitely is a 30, so we'll just fix that 30. There we go. And the bus station in your neighborhood is 35 kilometers, but that definitely says 25 kilometers, so we'll just fix that there too. There we go, east of the tower. Okay, calculate the distance you travel when you take a bus from the bus station to the airport. Okay, so we're going to start here. This is our initial position, and we're going to the airport. This is our final position. So there, right there, is that's the path we're following. Okay. All right, so our distance is going to be interesting to calculate. So we see we have some negative numbers over here. So what I'm going to do is I'm going to cut this up into two pieces right there, and we're going to do this piece and this piece. So I'm going to do D1 plus D2. Now remember, there's no negatives here. Okay, so I'm going from 25 to 0. That's a distance of 25 kilometers. And then I'm going from 0 to negative 30, which is still 30 kilometers. It's just in the negative direction. Okay. When I add those two numbers together, I end up with 55 kilometers. And so that's the distance that I'm traveling. To do my change in position, okay, this one's going to have a bunch of negative numbers in it, but it'll be okay. My final position is negative 30, and I'm going to be subtracting my initial position, which is 25. Forgot my kilometers. Okay. When I plug this into a calculator, I'm going to do negative 30 minus 25, and it's going to come out with negative 55. Okay. Or if you like to do the math in your head, a negative minus a negative, you add those and keep the negative. Okay. Kilometers. So notice that my distance and my displacement are almost the same. The only difference is that I have a negative here, and that's because the negative indicates direction. So I traveled 55 meters in the negative direction, so the value is the same, but the negative is there for the direction. Okay. So to recap, when we say xi, we're talking about the initial position. When we say xf, we're talking about the final position. Delta x means change in position, and you find that by doing xf minus xi. This one only works in a straight line, so you have to be careful with that one. If you're going in a straight line, you can write it this way. Those are little absolute value marks where you can literally just drop the negative and you'll have the distance, but that only works in a straight line. Only. Okay. Or we're using D for distance. Okay. All right. If you have any questions or that went too fast, go either watch it again, slow it down, take a break. Ask your teacher for help if you don't understand what's going on here, especially if you struggle with the math here. We are going to be doing some math, but your teacher can help you with that. Okay. Thanks for watching.